What's up, guys? It's Mr. Bringle, and today we're going to talk about the difference between scalar and vector quantities. These are things that we use in physics all the time, and it's really going to play into pretty much every unit that we have. So we need to know the difference. We need to know specifically about vectors because they include direction and how that works. So we'll talk about that and kind of lead into our unit on distance, displacement, speed, and velocity, and kind of how this works with that. So first thing here that I have down is that scalar quantities have magnitude, meaning it tells you how much, okay? So if I wrote down let's say that this ball down here, this ball rolls along the ground all the way to this point over here, and let's say that that is 5 meters, okay? So the magnitude here would be the 5. That's telling us how much. So if I write down 5 meters right here, I'm going to circle the 5. Okay, that is telling us how much. Okay, or if we were looking at a time and we said, okay, it took 10 minutes, right? 10 minutes. The 10 again is telling us how much. Okay. Now, this is different from a vector quantity because a vector quantity not only tells you how much, but it also tells you where, so the direction that the object is moving. So you can tell direction or show direction a number of ways. So you can just use directions like forward, backwards, right, left. You could say north, south, east, west. Or one that people tend to forget about is that if you put a positive sign or a negative sign in front of a number, that's also telling us direction. And that will make a little bit more sense when we start talking about displacement, velocity, and everything. But so to use these same examples, if this ball rolls to the right here, change my color, and instead of writing 5 meters, I might write 5 meters to the right. Okay, so the 5 would be our magnitude, and then to the right would be our direction. Okay, or I could have said something like 5 meters east. 5 meters east. Okay, those would be, again, magnitude and direction. One more example, just to show you, if I said that he moved positive 5 meters, that positive sign, the plus sign there, is telling us the direction. So in this case, I've defined the right as the positive direction. So if that ball had moved to the left, I would have put negative 5 meters. Okay. Now, because of the fact that vector quantities have direction, they can add and subtract. Okay. So where, let's say that the ball moves to that green dot and then it somehow somebody pushes it back. Okay, so it goes back to its original position. Well, the total, how much did it move? The total distance that it moved in that case would be 10 meters, right? So it went 5 meters to the right and then it went 5 meters to the left. So our total distance there would be 10 meters. However, if we were talking about displacement, which happens to be a vector quantity, we would have to subtract those. So we would say positive 5 meters one way and then negative 5 meters the other way, right? So when you use that positive and negative sign, it makes a little bit more sense as to why you would subtract those. So ultimately what that's saying is that the ball ended up in the same place, right? Its original position and final position were the same. And so it's the displacement of the ball is 0, okay? So same thing, 5 meters east and then 5 meters west, they would subtract from each other. So I'll just kind of write in over here, if we went 5 meters, positive 5 meters and negative 5 meters, right? 5 minus 5 equals 0. So that's that situation that I was talking about right here with the ball. If it moved 5 meters to the right and then 5 meters to the left, okay? If we're including direction, then ultimately that ball did not move from its original position, okay? So what I'm going to do here, I'm going to go ahead and actually erase this part right here. And then I've just got some examples over here. And these are things that we're about to start talking about. So things like distance and displacement, I've already kind of been talking about it, but distance is a scalar quantity. So what we wrote up there, 5 meters, is this would be a scalar quantity right there. Okay, now the difference between that and displacement is that displacement does have direction. Okay, so displacement, we just talked about an example of it. So another example here would be, we could write 5 meters north. Okay, so where the distance would be just 5 meters, the displacement is 5 meters north. Okay, and then talking about speed and velocity. So speed uses distance to calculate it. So it is a scalar quantity. And that would just be, again, if I just write something like 10 meters per second. Okay, that's telling us how fast the object is moving, right? And then if I were to do this with velocity here, velocity would be the counterpart to speed. It's basically just speed with direction. And so we use displacement to calculate velocity, and that should make sense, right? Distance goes with speed. They're both scalar quantities. Displacement goes with velocity. They both have direction, meaning that they are vector quantities. So if I were to go ahead and write this out, the counterpart here would be 10 meters per second. Let's stick with north, okay? All right, so that could be, for instance, some object that moved 5 meters and was moving at 10 meters per second north, okay? And that's just, you just want to be able to make that distinction and remember that distance goes with speed and displacement goes with velocity. They're often mixed up, so we'll need to make sure that we get that straight, okay? So in the next part, we're going to talk about the difference between distance and displacement, dive a little bit deeper into that.